Hi, thanks for joining us today. We're going to finish off lesson 6-6, and thus we're going to finish off all of unit 6 in this video. The last video covered the disk method, which is really only for the simple examples. This washer formula right here will be the key to everything. If you know the washer formula, you don't really need the disks, because a disk is just a washer with no hole. So what we're talking about here is big R squared, the outer radius from the axis of revolution to the furthest part. R, little r, will be the inner radius from the axis of revolution to the closest part of my region. Axis to closest bound curve. And this is the axis to the furthest bound. I can say farthest. Furthest is more often grammatical than farthest. The more you know. So what we're talking about here with the washers is we're talking about a situation like this. I have a squiggle with another squiggle. Oh boy, it would be great if you could give me a different color. With another squiggle. Okay? And here's the representative rectangle I would draw. But I'm revolving around this region, this axis right here. If you don't know what I mean by revolving, watch the first video. Please and thank you. So this revolution of this piece would make a big circle here. And the green one would also have its circle around the axis of revolution there. And the solid blue bit would just be this piece. Kind of like a lifesaver, a ring, a donut, or the actual mathematical term is called an annulus. When we have two circles like this, and I only want this outer circle, I only want the inner tube area, it would be pi times the big radius squared. So there's a center, they're concentric. They have the same center. We would call that the big R. And then this right there would be the little r. So we'd find the big area and we would subtract the small area, and that's how we get the area of these lifesavers. If you factor out pi, and that's how this is working. Okay? That's where this formula comes from. We're going to do a few problems here. This is highly important. There's almost always an FRQ using this idea. Here we go. All right. So we might see that 3a starts off with a disk. About the x-axis, we have a nice slice like this. The boundary, a boundary of this region, the axis of revolution, is a boundary. That's how we know it's a disk method. This axis of revolution is a side of the gray region I have here. So all I need for my volume is pi. I want to start these rectangles off at 0. It's the furthest, that's the lowest x value in this region. I want to stop them at 1. The radius here is top minus bottom. And the top curve looks to be negative x squared plus x. The bottom curve looks to be 0, and we'll square it all, because that's the radius. Just to be clear again, this is part, that's what I'm squaring, dx. That's it. That's review. If that doesn't make sense, you should be careful. You should go watch the other videos again. To be clear, you shouldn't trust pictures like that. To find the bounds in all of these examples, you're really using the equation x squared plus x equals 0, factoring to get x times negative x plus 1, x equals 0, comma 1. Okay? Now here, guiding you, this tells you the big radius. So we're going from the axis of revolution down here, my y equals 1. We're starting from the axis and we're going to the further bound, the farther bound, the farthest curve, the farthest part of my region. So that would be volume equals pi times the integral, and here's where we're going to get going here. That's still my representative slice. That slice still has to go from 0 to 1 to cover the entire gray area. But my big radius squared, the top of this length, the top of this length, the top of the brace is the parabola. And the bottom of the brace is my line y equals negative 1. So I'm going to minus negative 1. Notice the order of the parentheses. Notice it's this whole thing squared, not each piece. And then I'm going to have to subtract. Sorry, we'll use a different color, shall we? We're going to subtract this little radius guy squared. Now that's another vertical length. So we're going to do top minus bottom. The top is 0. The bottom is still the axis of revolution. So notice I have this guy squared minus this guy squared. That's it. You are done. You could simplify this to be plus 1. That's fine. All right. Now one more. One more time. I don't know why it selects all that. Whatever. All right. Now this time they don't draw the braces. My axis of revolution is y equals 2. I'm going to draw my big R. So that starts from the axis of revolution and goes to the furthest piece of my region. The furthest boundary of my region. That's big R. Big R always goes as far as you can in the region, to the farthest bit of your representative rectangle, which is still the same little guy in blue. Which means we're still going to have dx. We're going to still have the same bounds. It's just what's big R, what's little r. And little r will always start from the same point, but stop at the closest bit of the boundary. So little r, some students like this, little r is really measuring the whole. Big R is harder to describe what it measures. Outer radius, inner radius, just fine with me. So big R squared would be the top It's a vertical line. It's a vertical length. Top 2 minus bottom 0. That's it. And that's big R. Minus little r squared. So in this case, little r, top minus bottom. It's still a vertical length. The top for little r is still 2. The bottom for little r, and here's where your parentheses are really important, negative x squared plus x. We'd have to make sure we distribute that parentheses if we were going to do it. But again, all it's asking me to do is set up. So save yourself some heartache, save yourself some points. Just write it with parentheses, write it like this, you'll always get it right. 2 more examples. Here we go. Set up integrals for the volumes of the solids formed by revolving the region about the x-axis. All right, here we go. So I have x-axis. So I know I'm going to draw a rectangle that's perpendicular to the x-axis. It's already there for you. We know the big radius will start from the x-axis and go to the furthest bit of my rectangle. That's my big R. And my little radius will start from the x-axis and go to the closest bit on my rectangle. So that's little r. All right. But as soon as I know it's a vertical rectangle, I got pi, I got integral sign, I got some dx. Bounds. You should always notice your bounds are missing. Do not assume we are starting at -1 just because it looks like it. You won't get credit if it just looks like it. You need to solve this equation. And what do we solve? We solve by finding their intersections, everybody. Just some nice, good old-fashioned factoring. I messed up for a second. So starting from -1, stopping at 2. That's how that slice would have to travel to get all that gray area. It would have to travel from here all the way up to there. Left to right. Now my big radius squared. The top side of my big radius squared, the farthest reach of my big radius squared, it's a vertical line, top minus bottom. Top, what's this one? That's y equals x plus 2 minus the bottom, which is just the line y equals 0. Minus the little radius squared. So I'm writing that parentheses squared before I even write anything inside to make sure I try to get this right. Now, that one happens to be a parabola like that. So the top side of little r, top minus bottom, was x squared minus parentheses 0. And that's it. All right. About the line y equals 4. So my first step is to draw that line here. Womp. Now, does it hit this point? What's 2 when you plug it into these functions? It's 4, and it's 4. So it does hit that. Doesn't really matter. Perpendicular. We want it to be perpendicular to our axis of revolution. So I'm drawing this. Here's my representative rectangle. This axis of revolution is not a side of my region, so I'm definitely going to use the disk method. So we're still talking about volume equals pi. He still has to travel from the leftmost x-bound to the rightmost x-bound. -1 to 2. Still going to be a dx rectangle. And now let's talk about what's big R. So starting from the axis, we're going to draw a nice big brace to the furthest part of the rectangle, to the furthest curve. That's big R squared. In that case, we're talking about blue. This guy, top 4 minus bottom, x squared. If you write that square first, you're usually less likely to forget that square. A lot of your brains, trust me, my brain included, don't like seeing square square, don't like writing square square. You're just going to help avoid it. The little radius, the whole radius, not H, not WH, whole, but H whole. H whole sounds like a bad word. Little r, top bound, 4. It's always top minus bottom, and we're drawing little r just to describe that white space, sort of. And top, bottom. The bottom was just the line, which is x plus 2. Parentheses, so we distribute. Remember to subtract with parentheses, and you'll be doing better than 90% of the students out there. That's it. All right. Important closing remarks. I don't know if you can hear that. I just dropped the pen. Wow, I didn't even know that was the title. When you're finding volumes using disks or washers, always sketch your region. That's been true for 6.4, 6.6, and 6.5. I don't know why I went out of order. Your figure will help you decide whether to use x or y, whether to use dx or dy. The other most important thing is your rectangles must be perpendicular to the axis of revolution. The mnemonic for this is the phrase perpendicular, which I know sounds ridiculous, but it might help you when you are using washers or disks. The figure will also help you choose whether using disks or washers. Final words. All x with dx or all y with dy. I will also point out that we would use washers whenever axis of revolution is not a boundary, a side of my region. Meaning the reverse is true. You'll use disks only when, the disk method. Let's be really clear here. I'll just write this. You're only ever going to use this formula only when axis is a side of the region. Oh, sorry, the axis of revolution. Okay. Washers will always work. A washer, going back to this picture, is just a disk without a hole. If we made that 0, we'd have pi r squared and be done. I'd highly recommend you try out the homework. Once you finish that, do work on 6-7. It's imperative that you understand this stuff before the AP test, and certainly before the Unit 6 test. Good luck. Talk to me if you have any questions. Have fun with the homework. I know you can do it. Thanks for watching. Bye for now.